So I'm just going to make a quick video of how I would measure body voltage to demonstrate the AC coupling effect of a domestic property, the wiring, the AC wiring. So what we have here is a typical bedroom where we have, in this case, there is an extension lead leading from a socket in the wall there to a lamp, and another extension there with what looks like a mobile phone charger. So what I'm going to do is three measurements, one with the power turned on in the bedroom, and I believe this is the only socket there is another socket there, but that one's turned off and there's nothing powered on that socket. So I'm going to do a measurement with the power on, so I'm going to turn this on, and I'm going to do a measurement with the power off, and then I'm going to do a measurement with the power at the breaker box turned off. So what I'm going to do first is check that this socket next to the power socket has a correctly wired earth, and it does. So I know that that earth is going to the house earth, and it's correctly wired. It doesn't mean that there's no harmonics or frequency on that earth connection, but for the purpose of this test, it's good enough to test the body voltage, because what we're looking for is a difference between 0 volts reference, which is the house ground, and the voltage on our skin. So what I'm going to do is I'm going to stick this in here. Now all that is the earth pin only is connected to the shielding on this cable. I'm going to connect this cable to the earth pin of the multimeter there. I want to turn the multimeter onto AC voltage, and what I'm going to do is just take my voltage there sat just on the bed there. So we have 6.8 volts on my skin there. So all I'm doing is, so I'm just holding that, and it's picking up about half a volt actually just in the air there. So when I touch it, I get nearly 7 volts, 6.8 volts on my skin. So that's with the power turned on. So what I'm going to do is turn that power off, and again I'm going to measure my body voltage. So it's dropped about 1.8 volts, but you notice we still have, even with the socket turned off and the socket over the other side of the room turned off, we still have over 5 volts on my skin. So that's what I would be experiencing if I was lying in this bed asleep, and I've seen much higher voltages than that in bedrooms as well. Typically 10, 12 volts wouldn't be anything to be surprised at all. So what I'm going to do now is I'm just going to pause this video. I'm going to go downstairs and turn the power off at the breaker box and come back and then make another measurement. So it won't be a second. So now I'm back. I've switched the power off at the breaker box coming into the house, so we have no power on in the house. Exactly the same setup. I'm now going to set my body voltage with the power turned off, and we have 0.1516 volts. So it's dropped dramatically to less than 2/100ths of a volt. And but what we saw was that there was significant voltage even with the sockets turned off. You know, I had 5 volts on my skin then, and that's due to the downstairs lighting wiring and the upstairs socket wiring, just the wires running through the floor, which are energized when they're turned on at the breaker box. Even though there's no device or appliance plugged in and turned on at the socket, we do have energized wires in the floor space, and that's what's creating the voltage on our skin.